In the quantitative reasoning section, you have to do some fairly straightforward arithmetic and apply some ideas about things like percentages and percentage change, but to some data which you have to make sure you've understood, because there tends to be quite a lot of it, sometimes presented in various different ways, and it's about making sure that you find the right data and then apply the maths to it correctly. It's around where you have to be quick again, and if your mental arithmetic is very good, you may be able to do some of the calculations in your head, but that's not really what this is about. It's mainly about using the calculator that you're provided with effectively so that you get things done quickly. It's really imperative that you practice using the on-screen calculator. So if you do this test, it provides that for you. If you do the official UCAS ones, it does. Some of the other sites also do, and it's really important to do that, because otherwise you can find that just using the sort of slightly clumsy calculator can become the rate limiting step, and that's really not what you want. So let's have a look at the first of these questions. So the way this works is that they will generally give you a data set and then ask you a bunch of questions on those same data. And so it's worth taking just a little bit of time, first of all, to make sure you've understood what the data set is they're giving you, because once you've got that, then actually doing the questions is usually quite quick. So that means looking at the graph, making sure you've understood what's being shown, but also not ignoring the waffle at the top, because sometimes there's important information buried in that you need in order to interpret the information from the graph itself. Okay, so in this case it's pretty straightforward, because you've just got a newsagent who's looking at the goods he sold each separate day of the week and then breaking that down into the different kinds of goods. And the important thing is that this vertical axis always runs from 0 to 100, because he's breaking it down as a percentage. So each of the coloured bars represents what percentage of what he sells each day is a particular kind of thing that he sells. They're not absolute amounts, and we haven't got that information. Nowhere does it tell us here what the absolute amounts are, and that's important. Okay, so let's look at the first question, and it says, which of the following pie charts represents the distribution of items sold on a Sunday? So this is Sunday. That means we only need to look at that bar. And you can see that the biggest thing sold is the newspapers, and that's something over 40%. So what you're going to need is this blue region to be translated in a pie chart to something that looks like it's getting on for half of the total area of the pie, and the only one that could possibly be is this one, because you can see for all the other ones the blue area is pretty small. So you can immediately rule those out and say that one has to be C, to account for the fact that it's more than 40% of the goods. So that was a fairly straightforward question. So now it's telling us that on Wednesday he sold 280 items. So now we've got the specific information about what the actual numbers are. And it's asking us, of those 280, how many were sweets. So first of all, I've got to make sure we're looking at the right bar, which is this one, which is Wednesday. And what we need to know is what percentage were sweets, and then we can turn that into a number. So looking at that, it's the height of the maroon bar is the sweets, and the maroon bar is between 40 and 15. So we can get that the percentage that's sweets is 40 minus 15 is 25%. So what we're looking for is 25% of 280. So that's just a quarter of 280. If you can do that in your head, then great, because a quarter of 280 is 70, so that's your answer. If your mental arithmetic isn't that quick or isn't that reliable, then don't try and do it. Just plunge in and do it on the calculator. That's just up to you. But 25% of 70, of 280 is 70, so that was the right answer. Okay, let's look at the next one. So now it says that in the same week last year, he sold 2,480 items, but this year he sold 15% fewer. So how many did he sell this week? So that means that if he sold 15% fewer items, he's only sold 85%. So the quickest way to do this is to find 85% of 2,480. So that's 2,480 times 0.85, which is 85%. And that comes to 2,108. And so that immediately gives you your answer. So you didn't need the graph at all there, because it's just based on the total amount sold, and so that was straightforward. Now this next one possibly looks a bit more straightforward than it really is. So it says, on which day did you sell the most sweets? So you might think, okay, well, sweets is the maroon one, so I'll just look for the one with the biggest maroon bar, so the biggest percentage of the sales were sweets, and that's Saturday. But actually that's not the answer, because that just means that of however much stuff he sold on Saturday, that was a bigger percentage than it was on any of the other days. But of course he might have sold different amounts of stuff on the other days. So if we just sort of put some numbers on that, just to sort of make sense of it. Suppose he sold 100 items on Saturday, and we're saying, looking at the size of that maroon band, that's about 41%. So 41% of sweets. So that means he sold 41 sweets on Saturday. Now on Friday, maybe he sold 200 items. We don't know, but this is a possibility. So he may have sold 200 items on Friday. Only 25% of those, looking at the size of that maroon bar there, 25% were sweets. But 25% of 200 is 50 sweets. So even though he sold a much smaller percentage of sweets out of his total things he sold on the Friday, the actual number of sweets would be bigger than it was on the Saturday. There's no reason to think that is true, but the point is it could be. And so the answer to the question is can't tell. So that's really important. It's just about, when you're rushing, trying to save time, just pausing and think, all I could tell from this is which day he sold the biggest proportion, but that's not the same as the biggest number unless I've got guarantees about what the total number sold each day were, and you've got no information about that. So can't tell is the answer on that one. So now we move on to a new data set. So again, just very quickly, it's useful to scan through that and check what information we've got so that we know where to look for the relevant stuff when we come to the questions. So reading on the left-hand side down here, we've got the background that she's having 3 friends round for dinner. We've got a list of all the stuff she needs. And then over here on the right-hand side, we've got some information about these 3 shops she might possibly buy it from. 2 things really. First of all, the distance to shop 1. We're told only to shop 1. But we've also got the price information for 3 possible shops, including that one. So first question, if she buys all of her ingredients from shop 2, what's the cost per person? So again, this is fairly straightforward, but there are traps. The first trap is that we want cost per person. So all we can do is add up the total cost based on the items and then divide that by the number of people. And the big danger is that you'll say, 3 friends, let's divide by 3. But of course she's going to eat as well, unless it's going to be a very weird dinner party. So it's actually going to be 4 people eating. And so once you've got the total cost, you're going to divide by 4, not by 3. And the second thing is that there's not exact correspondence between the amount she needs and the amount that the prices are quoted for. So easiest way to do this question is basically by just adding up the total from the list, but just noticing beforehand whether any of these numbers need to be multiplied up. And you can see that we've got 600 grams of extra lean minced meat, but we're only given the price for 300 grams here, so that is going to have to be doubled. Okay, so we're going to need ×2 on the minced meat. But everything else matches. So we've got 1 packet of taco shells, yeah, 1 lettuce head, yeah, 1 sachet of spice, yeah, 1 jar of salsa, yeah, 1 packet of grated cheese, yeah. So all those are fine, but we've just got to remember that we need 2 packets of minced meat, and then you just add all that lot up together. So again, you can either do it on your calculator, but you can actually do it quite quickly in your head. So 80p plus £1.20 is £2. Then we got another £10 here because 2 lots of 5 takes us to £12. £13.60, £14.60, £15, £18. So it's up to you, but it's worth seeing how quickly you can do things like that in your head, because if it saves you time by not needing to go on the calculator, that's a really good thing. Okay, so I just went 80 plus £1.20 is £2, plus £10 is 12, 13.60, 14.60, 15, 16, 17, 18 pounds, divided by 4 people. So we just have 18 over 4 is 4.5. So it's £4.50 is the right answer. Okay, so easy, but also easy to slip up just by making small errors if you're not quite concentrating. Right, next one, percentage difference in price of a packet of cheese in shop 3 as compared to shop 1. So when you have percentage difference questions, it's important to be clear from the wording which one is your reference shop that you're calculating the percentage with respect to. And because it says as compared to shop 1, it means the shop 1 price is the reference, and you work out what the price difference is as a percentage of the price in shop 1. So make sure that that wording says that to you. That means that you work out what the price difference is and you calculate it as a percentage of the price in shop 1, because that's what you're comparing to. So a packet of cheese costs £3 in shop 3, £2.40 in shop 1, so the price difference is 60, and so the percentage difference is 60 over 240 times 100, and 60 over 240 is a quarter, so that's 25% is the right answer. So again, you could do it on your calculator, but you probably didn't need to do that, because you could probably work out 6 is a quarter of 24. So that enables you to do it faster, and if you can, you should, because time is going to be an issue here. Okay, on to the next one. Now this question is designed to try to trick you into wasting time, because it's actually a really easy question, but if you didn't stop to think about it for just a second at the beginning, you could easily start wasting time, because it says that she's going to buy her ingredients from shop 3, and it's wanting to know what percentage the lettuce made to the overall bill. But what you had to notice was this, that she bought all of this stuff plus some other stuff, and that all came to £20 altogether. So the total from these things is irrelevant. All we need to know is what percentage does this 90p she spent on the lettuce make out of the total of the £20, which comes from this stuff plus some other things. So the answer is just that it's 90p out of £20, which is 2,000 pence, times 100, okay, which is 4.5%. Okay, 0.045, which is 4.5%, and that gives you your answer, which is A. So just reading the question carefully, that was a very quick question. It's just what's 90 as a percentage of 2,000, or 0.9 as a percentage of 20, however you want to think of it. But if you didn't read the question carefully, you could easily, well, either get it wrong or spend ages adding all these numbers up and then realize you didn't need to know that. So although you've got to rush, you've still got to make sure you've read the question properly. Right, next one. Reads again quite complicated. Right, distance to shop 3 is 20% further than shop 1, but the route to shop 3 involves a motorway. You know, and you start thinking, oh God, this is complicated. So you've got to try to realize it's not going to be that complicated. They're not going to set you things which have multiple part calculations in all of this. So it tells you that what we're interested in is the time taken to drive to shop 3. So what you really need to know is the speed she's traveling at, which is 54 miles per hour, and you need to know how far it is to shop 3. Now, it doesn't directly tell you that, but it tells you that the distance to shop 1 is 15 miles, so the distance to shop 3 is 20% more than that. So that means that distance, if it's 20% more, that means it's 1.2 times 15 miles, which is 18 miles. Okay, either do that in your head or on your calculator, but that's 100% of 15 miles plus the extra 20% is 120%, so 1.2 times 15 miles. That's the distance. Speed is 54 miles per hour. So you can either sort of do this algebraically and say, right, speed is distance over time, which means that time is distance over speed, which is 18 over 54 is 1/3 of an hour, which is 20 minutes. And that gives you your correct answer. Or you could do that probably quicker by just saying, right, well, I can do 54 miles in an hour, but I've only got to go 18 miles. That's only 1/3, so it's 1/3 of an hour, and therefore I get 20 minutes. And it cuts out the algebra, but it just depends what you're most comfortable with. It doesn't take long to sort of scribble that kind of stuff down. But that was a slightly more involved question, but not as involved as it looked as if it was going to be. You know, we didn't need to know about the motorway and stuff like that. So it's just thinking, what was the information I needed? If I've got to find the time it takes for something, you've got to think, right, well, I need to know the speed and I need to know the distance, and just look for where you find those in the question. So by realizing what information you need and going in and finding it, it was quite quick, and you could just miss out the irrelevant nonsense that's in there. Okay, and on to the last question. Well, no, in fact, that was the last question. So bringing together the ideas from that section then. What you didn't get from that run through was the fact that you've got to be able to do that very fast. Okay, so speed is a big part of quantitative reasoning, as it is of all of the sections. But here, you've got to get up to speed. Now, part of that is deciding how good you are at mental arithmetic. You know, if you are quite good at figuring stuff out in your head, that can save you a lot of time. But obviously what you can't afford to do is get things wrong, or keep thinking, hang on, did I do that right? I better go back and check it. You haven't got time to do that. So if you don't trust your mental arithmetic, you'll have to rely on the on-screen calculator, and you're going to need that for some of the bits probably anyway. So the single most important thing you can do in preparing for this section is to really get used to using the on-screen calculator. Because if you haven't done, then it's obviously very different to plugging numbers into your own calculator, and you can waste a big chunk of the time just getting used to it. So that's the big priority with this. Similarly, you know, as with most sections, but I think perhaps for this one, almost more than any other, the whiteboard's really important. You've got to jot down your working so that you keep track of where you're up to, And if you're, for example, rearranging a simple equation, as in that last part, that's much easier to do when it's down in front of you than just relying on doing it in your head. So the whiteboard's really important. And then the third one is watch the wording, because as we saw in a couple of examples there, you could quite easily either get the wrong question, and not answer correctly, like the one where you realise that although you could say which day the guy sold the biggest proportion of sweets, you couldn't say which day he sold the biggest number. And that's where you had to be careful with the wording. Or at very least, you could just end up wasting time calculating a load of stuff that you then realised you didn't need. So read the question carefully, even though you've got to be quick. That doesn't mean you've got to be so quick that you risk misinterpreting the question. Okay, so as with all sections, if you practice, your speed will increase massively.